Hey everyone, myself Bhavya Goyal, a student at IIT Gandhinagar. I welcome you at CodeChef and let's have a look at this question. So yeah, today's question is monochrome minimization, the easy version. In this question, we're given n plus m points lying on a 2D coordinate plane. So out of these n plus m points, n of these points lie on the positive x-axis and m points lie on the positive y-axis. So if this is our coordinate plane, then n points lie on this positive x-axis and the m points lie on this positive y-axis. It is given to us that n is always greater than or equal to 3 and m is also greater than or equal to 3. And all of these n plus m points are at the distinct position. So no two points are present at the same position. Now we must assign a color, either red or blue, to each of these points. So if these are our points, then we must assign a color to each of these points. And the only constraint in assigning these colors is that there must exist at least one point colored red and at least one point colored blue on each of the axes. Besides that, we are free to decide the coloring. Now we define the monochromatic number of a coloring to be the maximum area of a triangle that can be formed by choosing any 3 points of same color. So you can choose any 3 points, any triplet which have the same color, and the monochromatic number is the maximum area by all of such triplets. So for example, in this coloring, one possible triplet we can find is this, which have some area. One particular triplet which we can find is okay. One particular triplet which we can find here is like this one. One possible triplet is this, one possible triplet is this, and so on. And the monochromatic number is the maximum such area. Now we need to find the minimum possible monochromatic number possible across all the possible colorings we can do. So we're free to do whatever coloring we want, and we need to find out what is the minimum possible monochromatic number we can get. If and in the output, if our answer is A, we need to print 2A, and it can be proved that the 2A will always be an integer. Now in the constraints, yeah, the most important part. In the constraints, we're given that n comma m would lie in between 3 and 2000. So a solution like n square nm or m square would easily pass, right? So we can think of some solution of that sort. This xi yi would lie in between 1 and 10 raised to the power 9. So the area can be up till 10 to the power 18. So we need to use long everywhere if we are using C++. Now we're given that no 2 points would lie at the same position and the sum of n and m over all the test cases would not exceed 2000. Now let's once see the sample inputs. In the first input, we are given a coordinate plane and the points are at 1, 2, and 3. And the other points are at again 1, 2, and 3. Now we can assign them a coloring such that this is colored red, this is also colored red, this is also colored red, and these two are colored blue. Right. Now what is the maximum color, like the maximum area with this red one? This is 3 minus 2. Right, this is 3 to 1, this is 1 2 3. The maximum area that we can get would be, if we like make a triangle of these red square, that would be 2 minus 1, which is 1, into this height, right? This 2 minus 1 into this height, which is also 1 by 2, which turns out to be 1 by 2. And we need to print 2 times this. So if we multiply it with 2, our answer would be 1. And for the blue one, there's just one possible triangle or triplet that we can get. And the area would be exactly the same, which is 3 minus 2 into this height, which is 3. Okay, wait, we can change the coloring here. We can just do this slight change. We can make this a blue and we can make both of them as red. And now this area would also turn out to be 1. So this difference is 1 into this height is 1 by 2, which is 1 by 2. And if we multiply it with 2, the overall area would be 1. And these are the only two triangles that can be formed. One is this, which has an area of 1 by 2, and the other is this, which also has an area of 1 by 2. right? And if you multiply both of them by 2, the answer would be 1, which is the minimum possible in this case. Now you can just try out the other cases by yourself. I'm not going to discuss, but let's move to the solution. So in general, if you're choosing any 3 points, what is going to be the area, right? So if we choose, let's say, these 3 points, so what would be the area? It would be the difference of these 2 points, right? Times the height of this, right? This height into this base into 1 by 2, right? So in general, the area is half into base into height, right? So now what would be the maximum area by just choosing the red points? So we have two options. Either we choose 2 points from the x-axis and one from the y-axis, right? Because if we are choosing all three from the x-axis, then the area would be 0, which would obviously not be the maximum area, right? So we can choose 2 points from the x-axis and 1 point from the y-axis, or the other option is that we choose some 2 points from the from the y-axis and 1 point from the x-axis, right? Now let's consider both the cases. So if we are choosing 2 points from the x-axis, the maximum area that we can get is the maximum position of red minus the minimum position of red, which would be the longest base we can get, into the maximum height that we can get. So the maximum position of the red point into 1 by 2, right? Which is what we have written here. So the maximum point which is colored red on the y-axis into the maximum point that is colored red minus the minimum point that is colored red into 1 by 2. Assuming we are coloring on the, like we are choosing two red colors on the x-axis, or the other option that we have is we choose two colors on the y-axis, in which case we would have maximum R, that is the maximum R we are choosing into the base, right? So that would be like if we are choosing these 3 points, then this would be the base and this would be the height. So height would be maximum R, the maximum R that we have into max Y minus the min Y, which is colored red into 1 by 2, right? Now in the blue area, you can just similarly figure out the formulas. And this is in general what the formula is going to be, right? For the maximum area. Now let's see the how should we color the points, right? So let's say we are given this as the coordinate system. And let's say we are trying to color this as red, this as red, this as blue, this as blue, and these two also as red. Now, do you think this would any time be optimal? So the maximum R over here is this. Let's consider them as 1, 2, 3, 4, 5, 6 only. So this is 6, this is 1. So this base is 6 minus 1, which is 5, right? But isn't it just better to minimize this difference because the other element is going to come on from the y-axis, which would just give us the height, right? And which we cannot change. That would just be the maximum position of the R, whatever, wherever that is. So isn't it like better to just keep them consecutive, all of them consecutive? So either we should place all of these reds together in the end or in the beginning, right? Because this is going to minimize the difference from the of the farthest points, and that is the only thing which matters to us. Now we have two options: either just place these all reds in the end or just place all of them in the beginning. And similarly, by symmetricity, we can say that on the y-axis also, if we are choosing 2 points on the y-axis, it's best to keep them as close as possible because the other element is going to come from the x-axis, which would just give us the height, and that won't really matter, right? So it would be better to either color all of them as red first and then blue first. We don't know how many to color to, like what color to color to how many of the points, but let's figure that out soon. But yeah, this should make sense that the coloring should be consecutive, right? For in any optimal solution. So this is our observation that in any optimal coloring, we would have a prefix of points which are colored same, and then the last suffix would be colored the same, right? Now we are given that n comma m is less than or equal to 2000. So can we brute force this thing, like the to calculate the minimum maximum area? So let us say that I comma j are the length of the prefix for the x and the y axis respectively. So x, like this I, represents that what is the length of points I'm going to color on the x-axis and y on the like j on the y-axis, right? Now we have multiple options that okay, we color this red, this blue, this red, this blue, or we color this blue, this red, this red, this blue, or we can color this blue, this red, this red, this blue, or this blue, this red, and this blue, this red, or whatever is left. So we would have those four possibilities, right? But by symmetricity, we can just color this y-axis to be red blue only or blue red only every single time, because that would be the same thing only. But for the x-axis, let's just iterate over the two possibilities. Now, what would be the red area? Maximum possible area of any triangle formed by only the red points. Right. So we have two options. Either choose 2 points from the x-axis or choose 2 points from the y-axis. Right. So let's consider both the cases one by one. So if you're choosing 2 points from the x-axis, then what would be the area? The maximum. This is the point, maximum point which we are coloring red. Right. So this x point I minus x point 1, this would be the base, into y point of j into 1 by 2. Right. Or if you are choosing 2 points from this axis, then it would be y point of j minus y point of 1 into this x point of I, right? This would be the maximum red area. Similarly, what would be the maximum blue area? It would be the max of these two values. Now, what are these two values? It is like the first possibility is we choose this as our height, so yp of m, and we choose the 2 points over here. So xp of n minus xp of this I plus 1, right? Because this would be the maximum base and this would be the height. Right, so this is like the triangle that is being formed. This is the height, and this is the length of the base. Right. Or the other option is we choose xp of n and choose this point and the this point, which is like yp of m minus yp of j plus 1. And if we take the max of 2, this would be the maximum blue area that we can get by this color. Right. And if we iterate over all such I comma j, we can just take the min, and that would be our answer. And this was the case one where we're coloring some prefix red and the suffix blue. Now the other possibility is we color some prefix blue and some suffix red, and you can just try to calculate or formalize these values yourself, and we can just move to the solution. But before solution, let's consider the time complexity. So the time complexity is n into m, because we need to iterate over all the pairs I comma j, and calculating this area is just a constant time operation, so the overall time complexity would be big O of n into m. Now let's see the solution in C++. So we'll begin by taking the input of n, m, x, and y. So we're using one-based indexing here. Now one very important step is we need to sort the x and the y arrays, because otherwise the algorithm will not work. We'll initialize our answer with infinity. We'll run a loop from 1 to n minus 1. Why till n minus 1? Because we'll be doing this j plus 1 here, so it's just fine. Now we're assuming that for here I'm writing that for x-axis it's always same, but it's the same thing, right? So you can assume that the red blue color is fixed for the y-axis, and red blue color, like we're trying the red blue color on the x-axis and the blue red color on the x-axis. Now this is the value of the red area, which would be the max of which the expression we calculated, and blue area is the max of the expression which we just calculated. And our answer is min of answer, comma, max of red area, comma, blue area. Because what is the maximum area which we can get by this coloring? That would be the max of both of these colors. And our answer would be minimum of across all possible colorings. And we'll simply print the answer. Now let's see the solution in Python. So yeah, we'll begin by taking an input of nm, the x points and the y points. We'll sort both of them. We'll initialize answer with some very big infinity. Will run for all the pairs I comma j from 0 to n minus 2. We're not including like the last point because we're just doing this plus 1 over here. Now we're assuming that we have red blue color for the y-axis. Just change this to white, so we're not going to do anything. And then we have red blue color for the x-axis or the blue red color for the x-axis. Now the red area would be the expression which we just calculated. The blue area would be the expression which we calculated. And the answer would be min of answer, comma, red area, comma, blue area, because red area is the like maximum red area we can get by this coloring, and blue area is the maximum blue area we can get by this coloring. And we need to just calculate the minimum possible maximum area, right? So the maximum area by this coloring would be this, and we need to just take the min across all the possible colorings. So we'll just take the min of it, and in the end, we'll simply print an answer. Now the time complexity is again big of n into m, because we're running an n into m loop, and all of this is constant. And yeah, that's pretty much the whole solution as well. I hope you liked it. Thanks. Bye bye.